survey of a number of reactions that add things across the carbon-oxygen double bond or carbonyl group, an aldehyde or ketone. And before we go into the details of the mechanism, I just want to talk about the things that you can add across the carbonyl group. So we kind of have a summary. What kind of molecules can be added across carbon? And we already saw that you can form a hydrate by adding water across the carbonyl group. So I'm going to just use a generic aldehyde here with the bar group and hydrogen, but the same reactions can occur on a ketone. And one thing that can be added is water by either acid or base catalyzed addition to form the hydrate. The net effect is to add a hydrogen to the carbonyl oxygen and the hydroxyl group as the nucleophile. Right? So the oxygen lone pair is the nucleophile. We're adding a nucleophile to the carbon, and we're adding an electrophile to the oxygen. So we can add water. We can also add alcohols. Very similar reaction. Start with an aldehyde, and by simply changing the solvent from water to, say, methanol, we can add the elements of methanol, the electrophile being the hydrogen, the nucleophile being the oxygen, just as it was before. And we've added the elements of methanol across the carbon-oxygen double bond to form a molecule that's referred to as a hemiacetal. It's possible in aqueous acid to go still further and add an alkyl group in place of that hydrogen to go all the way to a full acetal. So in this case, we've effectively added the elements of diethyl ether, right? Addition of ether. Across the carbon-oxygen double bond. We can also add amines. So a nitrogen work with a secondary amine, we'll actually get a different product. We'll get an enamine, and we'll see that later. So we can add amines. We can add thiols. Probably no great surprise, since sulfur is directly beneath oxygen, that if you can do something with oxygen, you can probably do it with sulfur as well. So if we simply use CH3SH instead of CH3OH, the acid catalyst is usually a Lewis acid catalyst. Boron trifluoride and zinc chloride are two of the most common Lewis acid catalysts for this reaction. And we will make the sulfur equivalent of this acetal, or thioacetal. And it will go through a hemi-thioacetal intermediate as well on its way to that thioacetal. So we've effectively added the elements of dimethyl sulfide across the pi bond, methyl group to the methyl group to the one sulfur, methyl group to the other sulfur. You'll notice that the oxygen is gone, it'll be lost as water. Another molecule that's important can be added across pi bond is the addition of hydrogen cyanide. HCN. Once again, we have the electrophilic hydrogen and the nucleophilic carbon, so we're going to add the hydrogen to the carbonyl oxygen. We're going to add cyano group to the carbonyl carbon. The cyanide is often introduced as sodium cyanide, and then either some acid catalyst or liquid HCN, that's the solvent. Which is a little bit dangerous because liquid hydrogen cyanide is quite toxic. But the result will be the same in either case. It will be to add a hydrogen to the carbonyl oxygen, the cyanide group to the carbonyl carbon, form a cyanohydride. And cyanohydrides is particularly useful because this nitrile can be converted by aqueous hydrolysis to a carboxylic acid group. So we make a new carbon-carbon bond, and we can convert the nitrile to a carboxylic acid, and thus to any carboxylic acid derivatives. Another molecule of importance that we can add across the pi bond is the peroxyacid. So in this case, we treat this with say peroxyacetic acid. across the pi bond. And this peroxide link is relatively unstable, so this reaction can go further. With an alkyl shift. Where the R group will actually move onto the oxygen to form an ester. Called Weyer-Williger oxidation. And it's a good way of inserting an oxygen. And finally, have the addition of phosphorus ylides. It's called the Wittig reaction. And ylide is a molecule that has a positive charge and a negative charge in adjacent atoms. In the case of a phosphorus ylide, we work with triphenyl phosphorus, and then a CHR minus sign on it. We're going to add cross pi bond. And we will actually end up making a carbon-carbon double bond. So I should be using bar prime for this. Sorry, bar prime for this. We already have bar group. So we've actually created a new carbon-carbon double bond between the carbon from the phosphorus ylide and the carbonyl. But initially, right, what will happen is the positively charged phosphorus will be added to the oxygen, and the negatively charged carbon will be added to the carbonyl carbon. So there'll be an intermediate. So it looks like this. Where we've essentially added the elements of this molecule across the carbonyl. So that's a summary of the reactions that we're going to be looking at in more detail. Addition of alcohols to form hemiacetals and acetals, addition of amines to form aminals, and then imines or enamines, depending on the type of amine. Addition of thiols to add thioacetals. Addition of HCN to form cyanohydrates. Addition of peroxyacids to form esters, and addition of phosphorus ylides to form alkenes. You'll notice that I wrote the Z isomer of the alkene here. The Wittig reaction is not particularly stereoselective, but to the extent that it is stereoselective, it favors the Z isomer. So that's a quick summary intro video, and now we'll move on and look at each one of these